Hi, so today we're doing areas of regular polygons. I'm going to start by answering the question of the day and then we'll get started. So the question was, what is the worst hairstyle you've ever had? So when I was little, my parents would cut my bangs, but instead of cutting them right around your eyes where they're supposed to, they would cut them right about here, just so they wouldn't have to cut them as long. So I went around for ages having bangs about this long. So make sure you answer that question in the 10.3 check-in at some point today. So we're going to have quite a few definitions today, just as a heads up. So a regular polygon here is a polygon where all sides and angles are congruent. So a polygon with all sides and angles congruent. Some of these are going to be reviewed from last time, but we're just going to go over them to make sure you remember them all. So here you want to have all the sides are the same, and then also all of the angles are the same, and that will give you a regular polygon. The radius of a shape then is when you come from the corner of a shape to the center. So you want a segment from the center to a vertex or a corner. So you're going to come from your center point right here, switch back to red. So this is your center, and then you're going to come to a corner. So this would be a radius, or you could have this would be another radius, but you're coming from the center to a corner. So this is your radius. And then apothem is a very similar idea. You're coming from the center, but you want to come perpendicular down on the side. So this is a perpendicular segment from the center to a side. And this perpendicular is really important. So again, you're going to come from your center point, and then you're going to drop straight down and make a 90-degree angle. So this would be an apothem. And again, you can go to any side and do this. So these would be your apothems. And we usually mark them with an A, so this would be an A. So some more review. Actually, not quite. We're going to do the area of a regular polygon. So this is going to be 1/2 NS A. And here you're multiplying all of these in between these. So N is going to be the number of sides. S is a side length. And again, these are all regular polygons. They all have the same side length. So it doesn't matter which side you pick. They should all be the same. So this is your side length. And then A is going to be your apothem length. So on the example over here, I'm going to label this and zoom in a bit. Here's our center point. Here's the apothem dropping straight down. This is going to be 5 inches. And then this side will be 6 inches. So I always start by labeling everything. So we need to find an N, our S, and our A. So N is the number of sides. So if you count, we have 1, 2, 3, 4, 5, 6 sides. So N is 6. The side length is also 6, and then our apothem is 5, and then you're just plugging it into the formula. So you want 1/2 times 6 times 6 times 5. And you can put this into a calculator and you'll get 90 inches squared. Or calculate by hand, I guess, if you really wanted to. So that's the definition of the area of a polygon. And go down, and then these next two are review, but you may have forgotten them. So a 30, 60, 90 triangle means on your triangle you have a 90-degree you have a 30-degree and you have a 60-degree. Across from the 30-degree, always, always, always is going to be your short leg. Across from the 60 is going to be your long leg. And across from the 90 is going to be your hypotenuse. And then you can find these using different formulas. So if you want to find your hypotenuse, you want to take your short leg and multiply that by 2. If you want to find the long leg, you want to take your short leg and multiply by the square root of 3. And if you're going backwards to find your short leg, you have 2 options. You can take your hypotenuse and divide by 2, or you can take your long leg and divide by square root of 3. So then for our example here, let's say that the hypotenuse is 10 centimeters and we want to find the other side lengths. You always want to start by finding the short leg because that's what the other 2 formulas are in. So we'll find the short leg first. So we want to take 10 and divide by 2 to get 5 for our short leg. We can then use that to find the long leg. So I'll move up a little bit so you can see that. We're going to do 5 times the square root of 3, and you can leave it like that, or you can get the decimal, which will be 8.66 centimeters. If a question on Math Excel or something asks you to leave it in simplified, or like simplest radical form, it wants this answer. So this is your radical form. If for some reason it wants that. Okay. Moving on, a 45, 45, 90 triangle is a similar idea. Here you want a 90-degree right there, and then 45 as your 2 other angles. Across from the 90 is still your hypotenuse, and then these 2 legs are going to be the same, so they're both just labeled as leg. Your hypotenuse formula is going to be your leg times the square root of 2. And then your leg is going to be the hypotenuse divided by the square root of 2. So if we do an example here, let's say this leg is 3 inches and we want to find the hypotenuse. You would take 3 times the square root of 2. Again, this is your simplest radical form, but if you type it into a calculator, you'll get 4.24 inches. So this is your simplest radical form. All right, so those are the definitions, and we're going to move on to some examples. So here we have the shape. We want to find the area of the regular decagon. So because this is a regular decagon, it's going to be a regular polygon. So we want our area times 1/2 number of sides, side length, and apothem. Again, I like to write everything down so I have all my different parts. So count your number of sides. If it says it's a decagon, that means 10, or you can count and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and have 10 for your number of sides. Side length here is going to be this, which is 8 inches, and our apothem, again, coming from the center straight down with a 90-degree, is going to be 12.3. And then you're just plugging it into your formula. So we have 1/2 times 10 times 8 times 12.3. Type that all into a calculator and you should get 492 inches square. We'll do another example. This one is a little bit different. So this one, again, we're going to find the area of the regular polygon. With apothem of 8 inches. So here's our regular polygon, and then it says we have an apothem of 8 inches. So coming from the center straight down, this is going to be 8 inches. So now we don't know anything else. We need to figure out what's the side length to this so we can get our different components. So here if we have our n, we know we have 1, 2, 3, 4, 5, 6 sides. We don't know what the side length is, but we know the apothem is 8. So to find the side length, we need to first draw a triangle. So connect to one of the sides and draw one of your radiuses. And now we have a nice 90-degree triangle, but we need to figure out what the angles are. you're either going to have a 45, 45, 90 or a 30, 60, 90 for all of our problems. So looking at this, if we split this like this, so draw in all of the radiuses, you know all the way around is going to have to be 360. So you can do 360 divided by the number of sides to get this inside angle, which is going to end up being 60. And then right here, this angle is going to be half of that. So this is going to be 30 degrees. So always take your number of sides, divide 360 by that, divide it in half again, and that's going to be your inside angle, which then makes this a 60-degree angle. So then across from this 30 is going to be the short leg, so we need to figure out what's the short leg. This right here is the long leg of our triangle. So if we have short leg here, we want long leg divided by square root 3, or 8 divided by square root 3. If you type this in, you should get 4.61. So this right here is 4.61. And then to figure out the whole side length, you want to double that. So 2 times 4.61 will give you 9.22 inches. And then you can use that to find your area. So 1/2 times our number of sides times our side length and times the apothem. All together, that's going to give you a area of 221.28 inches squared. All right, I believe we have one more example. So the last example is a honeycomb. It's made up of a hexagonal cell. The length of each side is 3 millimeters. We want to figure out what's the total area. So it'll be similar to what we just did, but instead of finding our short leg right here, we're going to find the long leg right there. So this is our short leg. This is the long leg. So we want to find the long leg. That's going to be 1.5 times square root of 3. If you type this in, you'll then get 2.59 millimeters. So our number of sides, we have 1, 2, 3, 4, 5, 6. Side length is this right here. So 3. And then the apothem is right there, or right here. So 2.59. And then you can figure out your area. Do 1/2 times 6 times 3 and times 2.59. Type this all in and you should get 23.31 millimeters square. So then here, again, we don't need to do this assignment. That's an optional assignment if you would like to do the Math Excel for 10.3 and the 10.3 check-in. All right, bye.